Hi, this video is to show off MicroSplat Trax and walk you through all of the parameters and the trade-offs involved in those parameters and the performance implications and some of the cool stuff you can do with it, and really make sure that you have a complete understanding of the system. So, I'm in the scene that comes with Trax. It's basically just a terrain with a couple objects that will roll down the terrain, leaving some trails. And the first thing you should notice is an object called the Trax Manager. In this scene, I just have it sitting here in the scene, and that's fine for what we're doing here. But in most games, what you're going to want to do is parent this to the player that the camera follows around. And what you'll see here is that this has a radius around it marked by this giant red circle. And that's showing me the area in which the Trax effect will show up. Beyond this area, it will diminish and fade away to nothing. And that's controlled by these two properties here, the buffer size and the world size. If I change the world size, then that controls how big this area is, from a very small area to a very large area. And for my case, I'm going to do it 200 meters out from the center of this object. And then the buffer size is the size of a texture buffer, a bunch of texture buffers that it uses. And so if you increase this, it's going to cost you more memory. If you decrease it, it's going to cost less memory. But the combination of how big that buffer is and how big the world is, or the area over the world that you're gonna have this effect, controls the pixel size of how small of an object can I represent in this buffer. And so that's actually displayed here as 0.2 meters is the size of a pixel on this buffer right now. So if I want to represent things that are smaller than about double this number, so smaller than about 0.4 meters, then I either need to increase the resolution of the buffer or shrink the world size to get more resolution. Now, in this scene, I'm just using these giant balls and stuff, so it's plenty of resolution, whatever. But that's something you're going to want to pay attention to. The other thing you'll see here is this layer mask, and what this is for is telling it what to render into the Trax buffer, which objects should interfere with the terrain and have an effect on it. And so usually you're going to put characters, cars, things like that in this. You're not going to put any static objects. You're not going to put the terrain because you want to just have the objects that interact with it in this layer. And you can, it's a layer selector, so you can have multiple layers. You don't have to have them all in the same layer. I just do because it's easier, so I just made a Trax layer and put everything on the Trax layer. When it works, what it does is it renders those objects from a special camera with a special shader. It's a very cheap shader into these buffers. And so it uses the visual representation of the object. It doesn't use like the collider. So if you have a skinned mesh like a dragon and he's got a tail and he's going to brush the snow around and things like that, that'll all work. You can make proxy objects if you want to render them into that buffer, but you don't have to. You can usually just throw stuff in. Where that becomes something that you kind of want to do is if you have something like a car, which tends to have two wheels that you want to, or four wheels that you want to interfere. You want them to leave trails, but you don't want like the bottom of the car bottoming out all the time. And so sometimes you'll model proxies to give it like an artificially high bottom of the car because, a sports car or whatever can seem very close to the ground. And what Trax actually does is it kind of pulls the objects under the ground for the sake of rendering. And then anything that's, under the ground is leaving a trail or an impression on the terrain. So, because physics won't let them really go under the ground, you have to consider that height. So when we press play, let's see what happens. So if these two objects that are falling, and right now I'm not using any tessellation, I'm not using any fancy effects. I'm just using Trax with the standard core modules terrain. And what I've set up is that it changes the texture from one texture to another as we roll over this. And you'll notice at places where there's not full contact, we get little gaps in it, which is what you want if something leaves the ground for a second. You'll also notice that right now it's using a different texture for each of these terrains. And that's for that we have to get into the shader settings for a second. So let's just switch over to the terrain. So I select my material, And if we go down to the Trax section, you'll see that there are two options here. There's a Snow Trax option, and then there's the Trax Texture option. And Trax Texture has a couple different options. It has none, which means don't do anything. It's just turning off the whole effect. It has a no texture option, which means that you'll only have things like color tint and stuff and normal strength to create the effect. So if you just want to darken the textures under it, something like that, then you don't need to use a texture. Single texture provides a single texture for all of the terrain types, and array gives you a texture for each texture that you have on the terrain. So you can have a separate set of textures for when grass gets run over versus when these rocks get run over or stone or whatever. So that's super powerful because it means you can customize so that when you run over sand, you get like sand tracks. When you run over like grass, you get mud. You know, you can control all those things independently. So when you go down to the actual tracks area of the shader here, you'll notice it has a diffuse height and normal, and these are looking for texture arrays. So because we're using the array mode, what we have to do is go here to our texture array config and turn on Trax Array. And what this will do is now you'll notice that, I'll pull this out so you can see it a little better. Here's my normal textures that I've packed. And here on the Trax Array, we have these additional textures that we can specify. So essentially, whenever the terrain is this texture, it's going to use this set of textures for the tracks. And whenever we run over this moss here, it's going to use this set of textures. So that's super powerful because it means that you can control the look of every, basically give every material kind of a sub-material, right, on your terrain. For the next thing, I'm going to turn on snow. So the single mode just takes two textures, and what it takes is a texture which is packed the way that I pack my textures internally. And that's all described in the documentation. But essentially, oops, I wanted that on rich. Essentially, the height map gets packed in the diffuse albedo, and the normal map gets its channels kind of moved around, and it ends up with the smoothness and AO also in there. And you can look at the docs and see how to pack those textures. The reason that you do that is a trade-off of speed versus quality. So looking up less textures makes the shader faster. And for the Trax textures, it didn't make sense to have all the kind of options I have in MicroSplat because there tend to be effects anyway. So I've turned on snow, I'm going to turn on tessellation, and I'm also going to turn on snow tracks. And this will let that same stuff. Now we can see we have tracks in the snow where those tracks were. And I'm going to go ahead and restart it so you can see it actually happen because it's kind of more fun that way. And so now we see that because we have tessellation, it can really dig into this terrain and create, you know, an actual surface here that we can get inside and everything. And so that's really cool. And you'll notice these little bits of terrain coming through, and you'll notice that those are actually the Trax texture that we specified in that array because we still have the array feature on. So let me just show you some of the properties here. When here's our normal snow properties, our tessellation parameters, and then when we go to the Trax section, we have a bunch of settings here. So for the array texture that we were talking about before, we have those two arrays that we generated with the texture array config. And then we have a global like UV scale to render those textures at. And then we have a texture blend amount and a normal strength amount, which controls how much of that effect is coming through. And then we have something very similar for snow tracks. So here we have a diffuse and height map and a normal pack in that packing I was just talking about for the snow when it has been depressed. And so the advantage here is that we can make a different snow texture and make that texture look different. Maybe it's got, you know, really beat down snow versus fluffy white snow, etc. And then this is actually a UV scale multiplier. So at 1, it's going to be the same size as the snow is. At 2, it would tile twice as much, right? And then we have a tint control. So if we just, you know, wanted to give the snow a little tint, we can do that. And here we see those texture blend and normal strength modifiers. So if I turn off the texture blend, then we're not going to see any of the texture effect that we normally have. Okay, and if we turn off the normal strength, that's going to control this fake normal that I generated in the shader. And that really helps kind of bring out this effect so that it's more visible because it's also in the normal map. So now we get to erosion and height clearing. If I turn those all off, it's just going to go straight to that snow texture. But if I use height clearing, it's going to actually bring in little bits of the original texture based on the height map. And if I do erosion, it's going to do a little bit of it based on the slope of the normal, essentially. And so using these two, we can determine how much it should clean the snow underneath of it. And you can use this to create kind of a dirty snow, or use it if you were doing a game about, mowing driveways, snow blowing driveways, and you wanted it to get down to the asphalt. Okay, so then you can just turn, these all the way up, and you'd get that kind of look. And then finally, you can control the crystals of the area in the ice, and the crystals setting controls kind of the specular response. So here we see, as we boost that up, we get this kind of sharp specular, and this is only for the snow that's depressed, and versus the snow up here has a crystals value for the undepressed snow. Okay, so I'm going to put that at like 0.8 or so we get a little bit of that kind of packed, shiny, icy snow kind of look in there, and the rest of the snow stays sort of fluffy. So this gives you a lot of control over how those two things look. And we also have here, we have per texture property settings, okay? And so we have an opacity for the effect on this particular texture. This is for the opacity of the array, or single mode, if you're on that. We have a normal strength for that. And then we have dig depth, which controls how much it affects the tessellation. So if I turn that on, and then I adjust this, you can see that we can adjust the tessellation, like how much this is pushing us down with this dig depth. And then finally, there's a Trax tint color for each texture in the array, or if you're using that no texture mode, you can use that to specify the tint. So yeah, super configurable. And there's one more thing I'm going to show here. I'm just going to take off the snow for a minute. Turn that off, let it compile. And I'm going to do something kind of silly. It might have a use, but I'm going to turn on lava. So normally, if we turn on lava, we'd either paint lava somewhere or use the dynamic system to pour it over the terrain, something like that. But when Trax is enabled, you can actually tell it how much to put of any of the 4 effects into the Trax texture. And so there's this Trax levels here. Maybe I'll give that a better name or label it or something. But basically we have these 4 values that correspond to wetness, puddles, streams, and lava. I'll probably turn these into sliders at some point with labels so that they're a little more easy to read. But if I set this to 1, you'll see that I get lava in my Trax, which is super cool. And as I move that down, it's going to go through the stages of lava, of being, burned, and then full lava as it comes down there. And if we were to turn on wetness or puddles, we could do the same thing, streams, etc. with that. And so what this is useful for is you might, if you've stepped in the mud before, maybe you step deep into the mud, you lose a boot or something. When you do that, often what you see is that the depression that you leave behind is kind of filled up with water and it looks wet. And so that can give you that look. But with another feature, we can actually make it so that you get a puddle in there and then the puddle kind of goes away over a second or so. And so to talk about that feature, I'll just leave that on for now. I'm going to go over here and actually let's turn on the lava a little bit and we'll show what happens since we've already got it on. Put this to 1. So here we get lava in the Trax, right? So now I can go to my Trax manager. I'm going to go ahead and stop because I'm going to turn on what's called the time manager. Now, the time manager has a bunch of settings, but right now what I'm going to do is set the repair time to 5. So that means it's going to take 5 seconds to repair anything that's with the tracks. And so now what we see is that, you know, our lava fades away, or our wetness or whatever effect we wanted fades away over time, turns into the burn, and we get rid of it. And that's kind of that repairing tracks thing if you want to do that. If you know, in most games, like when you're leaving snow trails and things, you don't want to do that. You just leave the tracks around as long as they take. And you can set that time to be however long you want. There's a couple other options on here too. Now, if you make any of the other two options non-zero, then it's going to increase the amount of memory that it needs for the buffer. And that's because these other two options need to store some information per pixel in the tracks buffer, so they use another channel. And they are repair delay, which is basically how long until I start repairing. So I might say it takes 3 seconds before I start repairing, and then it takes 5 seconds to do the full repair, okay? Or it could be, you know, a long time, short time, whatever. And then I might say that, well, it's going to take 5 seconds to do the total repair is 5 seconds long, but I'm going to stop at 2 seconds. So what will happen is it's going to come in, and let's just, for this demo, we'll just make it 1 second here for the delay. It's going to wait 1 second, then it's going to start repairing. It'll take 5 seconds to repair, but 2 seconds into it, it's going to stop, okay? And what that's for is that you can make things repair a little bit and still keep their tracks. So we can see that this is repairing, okay, but it's not repairing all the way. And so we could tune this so that the lava, let's see if we can do it really quick. Let's just say 3 seconds on repair. I'm going to 1 second delay, and then it's going to get about 3/5 of the way to fully repaired. So you can see here the lava is fading away, and it's stopping at sort of a burn state behind it. And you could tweak this to get it to be fully burned or whatever. You can do the same thing with the puddles. So again, you could put puddles in these and have them slowly repair a little bit and then stop after a second, so that you still have, you still end up with basically your mud texture there, but you've repaired some of this damage to it that is the part that's creating the wetness. So that's pretty cool because it means you can have kind of stages to this thing. And the other thing that gives you too is that if you run over it again, okay, then, in fact, I'll just do that with an object here. I've got this object sitting around, and I'll need to switch to the scene view for that, but let's go here. So we can see those are damaged now, right? You can come in here and just create some more damage, right? Boom. Ah. I went right through the ground, so that was a bit much for it. It didn't go as much as the... Such a hard time moving around in this thing sometimes. So let's just bring it down a little bit like the cylinders were. The cylinders were basically at terrain height. So here, if those cylinders were rolling over this, you can see that the repairs, but we still have something to roll over each time and kind of reset it. So if you were doing a game where, you know, cars going through thick mud, you can keep running over those and getting an effect, getting a reaction, right, a visible reaction, but not where the tracks go away and there's no track there anymore. So that's super cool because you can kind of have the persistence of the trails, but still have things repair enough that you get an effect each time you run over them. So let's talk about the advanced controls. So I just threw these under an advanced because generally you don't want to mess with them too much. They tend to come into play when you have very fast moving objects. Because this is rendered like everything else in your frame rate, it suffers from frame rate issues if your frame rate is slow, which means that, like, if I'm in a racing game and I'm moving at high speed and I'm running at 15 frames a second, well, the physical position of the tire from frame to frame may jump, right? It may jump 3 tires forward each frame. So you're not going to get a smooth trail. So the first thing is you got to have your frame rate enough to produce a smooth trail. The other thing that happens is because of the way the effect works and because I don't know where the terrain is, which is a big rendering savings when I'm rendering the buffers can look a little crunchy if you don't post-process them. And so there's a blending amount, which is kind of like a smartly controlled blur on the buffer that it'll do. It'll do it every frame. And so each frame, it'll kind of do this conservative blur to kind of get the edges to look right and not be too sharp or too scraggly, right? And if you're going at very high speed, then sometimes you can see what looks almost like a digitalness to it, like little triangles almost. And running that buffer can help with that. And this buffer blitz setting here says how many times do we want to process the buffer per frame. It takes on a 2048 buffer, which is a fairly large buffer. On a 980 Ti, it takes about 0.08 milliseconds per blit. So it's pretty cheap. Like it's really cheap. But generally I find one blit is enough to get rid of all the artifacts. You might put it up to 2 or 3, but for super high quality or something. But usually within a blit or 2, which is doing it anyway as it's doing the frames, it will go away. And so if you find yourself in a situation with very fast moving objects, then those are the settings to change. The other 2 settings are collision distance. So, and you may have noticed this when I was trying to mess around with that sphere. When these objects collide with this terrain, they don't go through the terrain. The physics system fights desperately hard to make sure that doesn't happen, right? And it pops them back up to the surface. So you're never actually going down into the terrain and depressing it because you're above it, right? So the collision distance basically says, how much should I fake it? How much should I pretend that this object is lower in this terrain than the terrain really is, okay? And so when an object, when this is set at like 1 meter, that means that everything when it does the rendering for the collision is pulled down a meter. So if you're doing a game that is a different scale, it has lots of really small objects, and you find that things basically just produce these like, it's on or off, it's like binary, or if you're using tessellation, it's just like everything seems to just slam right to the bottom, then you probably want to lower your collision distance, so it doesn't pull them down so hard. And then sync strength it's kind of, it doesn't work in the sense of like, I want to make things slowly sink into the snow. But this is basically controls like how many frames it takes to reach its bottom distance. And so when you push this up higher, it's going to be more instant. When you push it low, it's going to take a little bit longer. And I do mean a little bit. We're talking in frames, like whether you're doing it instantly in the frame that you collide, or whether you're taking like 2, maybe 3 frames to fully resolve it. And that just kind of helps smooth out that transition along with the blur a little bit. So I've exposed these things. Most of the time, you don't have to mess with them. If you start seeing any artifacting, you may want to, increase your buffer blitz or play with the blend a little bit. Be careful with it. And then the collision distance, if you're using very different scales, you might lower that a little bit, something like that. There was something I wanted to say about, oh yeah. So the downside of this buffer blend, because again, I don't know the terrain distance, there's kind of a minimum fall off to how fast, I don't know how to explain it exactly, how fast a pixel can go in the blend buffer from where it's been depressed to what is effectively infinitely far away, right? And this is just kind of a clamp. And so that blur, if you were to put that down to like 0.01 or something, then essentially like the effect would be that stuff when it collides like here, it would end up creating tracks on the side of the hill where it didn't actually collide. So that's one thing. If you ever see that happening, it just means your buffer blend is way too low. But mostly you shouldn't have to set this stuff, and it will be hidden away here from you unless you do. So performance-wise, what does this cost? I did tests with a 980 Ti with a 2K buffer. World size doesn't really matter. I was doing a racing game with a couple cars running around, and the entire effect to render, to do the Trax manager and generate the buffers and all that. And this is in standard pipeline. In HDRP or lightweight render pipeline, it might be different when I do the support for that. But on standard pipeline, it took about 0.58 milliseconds for the whole effect with one buffer blit. So it's pretty fast. It does consume a lot of memory. And so you want to look at that and balance that. But you know, modern cards have 6 gigs of memory on them. So 20 megs of texture data is not really a lot. But if you're trying to squeeze into mobile or something like that, it does require floating point texture support, which most things have. Now, some mobile devices will not give you what you expect. You'll say, hey, I want a unsigned floating point texture with an R channel, and it will give you back a half precision float, or it'll give you back a signed float where everything has to be between a 0 and 1 value. And if it does that, then you're going to have problems with these effects. And I've seen that on some mobile devices. I don't know which ones offhand. There's too many. But if you see something going weird on mobile, then that's what it's probably from. If it gives you back a half precision buffer, that will probably work, except for repair effects. Probably you would have some problems with. And yeah, so I think that covers just about everything. If you have any questions, you got some feature ideas, let me know. There's a lot of stuff you can do with this, and it's just such a nice thing. It gives people such a good reaction when they move a character through the snow and it parts of snow, or something crashes and it makes a big skid mark on, on the ground. So yeah, hope you enjoy, and hope this explained, everything for you. And thanks for watching.